Well, welcome back from spring break, men. I hope everyone had a nice, relaxing time, that you enjoyed the beautiful weather, and were able to spend that time with your family. I miss seeing you guys, and hopefully we'll be back in the classroom by the end of the year. If not, then we'll keep going with this. But I do miss seeing you guys in the morning, and you know, I hope that everyone is doing well and staying healthy. Today we're going to move on to section 8-4. That's angles of elevation and angles of depression. It's going to be a short and sweet lesson today. So suppose a person on the ground sees a hang glider at a 38 degree angle above a horizontal line. So what we call the horizontal line is our eye level, our line of sight. So we got this young lady standing on the ground. There's her horizontal line. When she looks up to see the hang glider, she raises her head at 38 degrees, and now she sees the hang glider. So that would be an angle of elevation. So above a horizontal line, this is the angle of elevation. And that's because she had to raise her head above that horizontal line. At the same time, we've got a person in the hang glider. There's the horizontal line for the person in the hang glider. That person looks below this line to form a 38 degree angle to see the young lady standing on the ground. So if we have to look below a horizontal line, that is going to be an angle of depression. And notice that these horizontal lines, they're going to be parallel. So we have these parallel lines. So these angles of elevation and angle of depression, they are the same. So they are congruent. So if they're congruent, why are they congruent? They're alternate interior angles. So the angle of elevation will be congruent to the angle of depression and vice versa. So our first example here is what is the description of the angle as it relates to the situation shown. So angle 1 is an angle of depression, and that's from the goal to the hot air balloon. Angle 4 is an angle of elevation, and that is from the beach to the hot air balloon, or from the base of the cliff to the hot air balloon. Angle 2 is an angle of elevation, and that is from balloon to goal. And lastly, angle 3 is an angle of depression, and that is from the balloon to the base of a cliff. That's just how we're going to get used to writing in terms of identifying the angle of elevation and the angle of depression. Example number 2, suppose you stand 53 feet from a wind turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. How tall is the turbine from the ground? Well, we know that we're standing 5.5 feet here. So I'm standing 5.5 feet. This is going to be x, and x is going to relate from here to my eye level. So my final height is going to be x plus the 5.5. So x plus 5.5. That's going to be the height from the ground to the hub. So if I look, we're going to have to think back to what we learned right before the break. This is why it's a good refresher. I have 56.5 degrees. So this is the opposite side. This is the adjacent. So if I write SOHCAHTOA out, I have opposite and adjacent. I'm going to have to use the tangent. So I'll say the tangent of 56.5. That is equal to x over 53. And remember to solve for this. X is equal to 53. We got to cross multiply. Tangent of 56.5. We get that x is 80.07 feet. So then I have to add the 5.5 to it. So I get that the height is 85.57 feet, or 85.6 feet tall. Okay, you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet off the ground. So there it is. We have x as being the height of the climber. If I am standing 6 feet off the ground, I know that the height of the rock climber from the ground is going to be x plus 6. So x plus 6 is going to be the height. So I need to figure out what is the height. Again, if I look, I have opposite and adjacent. So this is going to be the tangent of 32. That is equal to x over 1,000. Cross multiply. 1,000 tangent of 32. That's what x is equal to. On the calculator, when you type that in, you get 624.87 feet. So then when I round or I add that, I get it is roughly 630.9 feet. To approach a runway, a pilot must begin a 3-degree descent starting from a height of 1,707 feet. So here we go. There's 1,707. I know that the angle of depression is equal to the angle of elevation, so that's going to be 3 degrees right here. Alternate interior angles are congruent. To the nearest tenth of a mile, how far away from the runway is the plane from the start of this approach? So the question is how far, and that's going to be this distance right here. That's how far the plane is from the runway. So that's where I'm going to place my x. So if that is going to be the x right here, I'm going to say that that is sine. So the sine, because this is opposite and hypotenuse. So the sine of 3 degrees is equal to 1,707 over x. So we cross multiply. X times the sine of 3. That is equal to 1,707. I divide it by the sine of 3. Divide by the sine of 3. So 1,707 divided by the sine of 3. All right. So x is equal to 32,616.2, and that is in terms of feet. But there are 5,280 feet for every mile. So I need to take this 32,000 and divide that by 5,280. we get about 6.2 miles. So it's about 6.2 miles. All right. So last one, this one doesn't have a picture. So we say a pilot sights a life raft at a 26-degree angle of depression. So I'm just gonna draw my horizontal line, and there's the line of sight. If you want to get another horizontal line, you can. It says so that they spot it at 26-degree angle of depression. So that means 26 degrees right there for the angle of elevation. It says that the plane is 3 kilometers above. So we could draw it over here as well. That's 3 kilometers. It says, what is the horizontal distance from the raft? That's this. So again, this is going to be a tangent type problem. So the tangent of 26 is equal to 3 over x. We cross multiply. X tangent of 26, that is 3. So x is 3 divided by the tangent of 26. 3 divided by the tangent of 26 is going to get me 6.15. And that's how far it is. So if you want to say 6.2 kilometers as well, that's fine. Like I said, this was a quick review. It's just an application of the sine, cosine, and tangent. I hope you found this review to be straightforward. You could check Schoology for your homework, and I'll see you guys later.